Beneath the hazy orange clouds of Saturn's moon, Titan lies one of the solar system's greatest mysteries. Out there is a world much like our own, something strangely familiar, but at the same time, it is alien and unfathomable. For decades, the surface of Titan was hidden from our view until NASA found a way to cut through the haze and reveal the moon's true nature. This is what they found. Our first close encounter with Titan came in the year 1979 when NASA sent a robotic spacecraft named Pioneer 11 to visit the planet Saturn for the first time and investigate the rings and moons that surround the gas giant. We've known about the existence of Titan for centuries. It was officially discovered in 1655 by the Dutch astronomer Christian Huygens. It's not hard to spot either. As you can probably tell by the name, Titan is big. It's actually a bit larger than the planet Mercury, and it's 50 wider than our own moon, but it's still incredibly far away. So, when Pioneer 11 first encountered Titan, scientists were eager to find out what it actually looked like. But all that the probe was really able to see were the dense orange clouds that surrounded the moon. It was impenetrable. What Pioneer was able to do was investigate what that haze was made of, and it found something very intriguing: a thick atmosphere that was rich in nitrogen. This is very similar to what we have on Earth. The majority of our own atmosphere is also nitrogen. Now, there was another familiar discovery made on Titan, and this is what really piqued the curiosity of scientists: hydrocarbons. What are those? Well, the technical answer is that they are carbon atoms bonded to hydrogen atoms. Most of us use hydrocarbons almost every day in the form of a combustible fuel like gasoline or propane. On Titan, the atmosphere is filled with methane, which we generally know as natural gas. Now, why is this important to NASA scientists? Well, a more practical explanation would be that in addition to being useful as fuel, these carbon-based structures are also known as the building blocks of life. Important molecules like DNA and protein are all built on hydrocarbon foundations. Here's a more familiar word for you: carbohydrate. Sounds pretty much the same, and it is, but carbohydrates bring oxygen to the party. So, if we can find oxygen on Titan, then we've got more than just the building blocks of life. We've also got the food to fuel that life. And just so you know, right now, there is oxygen on Titan, but we're going to need to go a lot deeper to find it. So, stick with me. Flying a probe close by, Titan was also able to give us a sense of the moon's gravity. And this is a bit strange because Titan has a lot less of it than you'd expect. For being so much bigger than our own moon, the force of gravity on Titan is actually a little bit weaker, meaning Titan isn't very dense, meaning it can't be made entirely of rock. And that opens up some interesting possibilities. The combination of a thick atmosphere and weak gravity means that a person in a wingsuit could essentially jump off a cliff and fly like a bird for as long as they want. It also makes a flying machine a perfect vehicle for exploring the surface. Writing clearly is hard. Whether you're explaining rocket engines, sending an important email, or just trying to make your ideas come across the way you want, you write a line, read it back, and something just feels off. That is where Quillbot's Chrome extension comes in. With one click, it can rephrase your sentence to sound smoother while keeping the same meaning. I find it particularly useful when sending email. So, say you're drafting an email to your boss or a client, and you want to sound more professional. Highlight the sentence, hit Quillbot, and instantly see polished alternatives. Or maybe you're writing a school paper, a LinkedIn post, or even a cover letter. Either way, Quillbot helps you get your point across with clarity and confidence. The extension works right inside your browser, so you don't have to jump between apps or websites. Anywhere you're typing, Gmail, Google Doc, social media, Quillbot is right there to help. And if you want to try it out, check the link in the description to install the Quillbot Chrome extension for free. Once you start using it, you'll see how much easier it makes your writing, whether you're working on something technical, professional, or just day-to-day communication. So, this is what NASA found back in the 70 seconds. A lot of very Earth-like ingredients hiding deep in the outer solar system. They knew that beneath the clouds of Titan could be a discovery that would change everything we know about life in the universe. It was so close, yet so far away. They would have to wait for technology to catch up. And 25 years later, in 2004, the Cassini spacecraft would finally arrive at Saturn to pick up where Pioneer 11 had left off. This was a joint project between NASA, the European Space Agency, and the Italian Space Agency. Cassini is equipped with the necessary radar and infrared scanners to see through the dense atmosphere of both Saturn and Titan. Over the course of its 13-year mission, the spacecraft would fly past Titan 127 times, using its instruments to cut through the haze and investigate down to the surface. What it found was mind-blowing. Titan is the only moon in the solar system with an atmosphere. And this is a thick atmosphere, 4 times the density of Earth's. So what that does is it actually creates a reverse greenhouse effect, blocking out what little heat from the sun can actually reach this far. So, as we move deeper towards the surface, all of the methane gas in the air gets colder and colder until it liquefies and falls like raindrops onto a surface of ice that is frozen as hard as granite rock. The average surface temperature on Titan is -179 C, and the freezing point of methane is -182. So it is the perfect environment to support a full hydrological cycle of evaporation and condensation, except with rocket fuel instead of water. The result is flowing rivers, lakes, and seas across the surface of Titan, making it the only known world aside from the Earth that has a stable liquid on its surface. Now, the people who built Cassini were very smart. They knew that Titan was going to reveal something incredible. So, the European Space Agency included a secondary probe, the Huygens lander, named after the Dutch astronomer who first discovered the moon. And it was designed to parachute down to the surface and take photographs of Titan along the way. In January 2005, Huygens began its descent. Based on images taken by Cassini, the target landing site was believed to be the shoreline of a small lake. The probe had been designed to survive landing on a variety of terrain, from mountain ranges to flat plains and even a liquid ocean. It had enough battery life to operate for 3 hours, with 2½ of those hours being spent slowly parachuting down to the surface. And when Huygens finally broke through the clouds on Titan, this is what it saw. We begin to make out a dark valley set between brighter mountain ranges. And as we get closer to the ground, in the middle of the frame, you can clearly see a network of drainage channels and streams that have been cut into the sides of the mountains. Some of these would be hundreds of meters wide and several kilometers in length. These would have been created by runoff from methane rains working their way into the valley. Huygens is coming down right into the middle of that dark area, and as it approaches the surface, we can start to see that there is no liquid here. It's actually landing in a dried-up riverbed. When Huygens makes contact with the surface, it makes a dent 12 centimeters deep. It bounces and then slides about 30 to 40 centimeters across the ground before wobbling a few times and coming to a rest. As the camera begins to look around on the surface, the most striking revelation is not how alien the world looks, but actually how familiar this all seems. If you take away the orange color, it looks like the bottom of any river on Earth. We see large, rounded stones that have been smoothed over by flowing liquid, and they're surrounded by smaller pebbles on what looks like a sandy surface. Only these aren't rocks. They are chunks of water ice that are frozen as hard as rock. Same with the mountains. They are made of ice as well. Remember, water means oxygen, H2O. But it's still no good for life if it's frozen solid. And the muddy-looking surface around the lander is thought to be a strange hydrocarbon material that scientists found to be very much like snow, with a thin, crispy crust on the top and a soft texture beneath. As the camera looks out into the alien landscape, you can start to see waves in the air. That is, heat from the probe's lamp causing evaporation on the surface. At one point, we even see a small drop of methane dew drip down past the lens. As the camera pans up, we see the sun in the sky, and it's just 1/10 the size of how it appears from the Earth. And even though it's midday on Titan, the light is only as bright as what we see just after sunset at the twilight hour on Earth. So, what Huygens found was pretty amazing, but it did fail to uncover the most intriguing mystery of Titan, the liquid methane. It seemed to land in the right place, the bottom of a river, but it just arrived at the wrong time. So, where did the liquid go? One of the interesting findings from Huygens had to do with the moon's methane cycle. We know about the water cycle on Earth, right? Water evaporates from the surface and rises up into the sky, where it condenses into clouds until there's so much water vapor trapped up there that it starts to fall back down as rain. In most places on Earth, rain happens pretty frequently because there's a lot of energy from the sun driving evaporation. But on the surface of Titan, where there's only a very small amount of sunlight, the liquid methane evaporates very slowly. And when it does evaporate, all of the methane vapor gets stored up in this incredibly dense cloud cover that can hold on to massive amounts of rain before anything actually starts to fall. The result of which would be long periods of drought that could last for hundreds of years at a time, followed by periods of torrential rainfall that would cause flash flooding all over the moon. So, unfortunately, we did not visit Titan in its rainy season, but that doesn't mean that it was totally dry either. As Cassini continued on its 13-year mission, the spacecraft continued observing Titan and learning about its surface. What it found was that during the dry season, liquid methane is limited to the North Pole regions. And what the probe learned to spot were these bright reflections of sunlight shining off the tops of watery lakes. This is the first body of liquid methane identified on Titan. It's called Ontario-Lassus, named after Lake Ontario in North America. Because the two have a nearly identical shape, only the one on Titan is about 20 smaller, but it still covers about 15,000 kilometers. Even though the lake is pretty big, it's actually still relatively shallow, with the average depth between 40 centimeters and 3 meters. It's also an eerily still lake, with waves only reaching 3 millimeters in height. So to the naked eye, the surface would appear as flat and still as glass. Now, we're not sure why that is. Given the higher air pressure and lower gravity, waves should actually be bigger on Titan than they are on Earth. And Lake Ontario has some pretty big waves. Titan even has a small ocean at its North Pole. This body is known as Kraken Mare. It's 400,000 kilometers in area, just a bit smaller than the Black Sea on Earth. Large enough that it actually experiences a tide from the gravitational pull of the nearby planet Saturn, with the liquid methane rising and falling up to 1 meter. Although Kraken Mare is still relatively shallow for its size, around 300 meters deep on average, while the Black Sea reaches down over 2,000 meters. But lakes and oceans of methane are not the only active process still happening on Titan. There are volcanoes as well, only we know that the surface of Titan doesn't have rock. It has ice that looks like rock. So the volcanoes don't erupt with magma, they erupt with slushy water. Now, if Titan is so cold, then how is there any water that isn't already frozen solid? Well, the slush magma is mixed with ammonia, which acts as a natural antifreeze. You probably know ammonia as a foul-smelling cleaning product, but it was also very abundant during the formation of the solar system. It's just a combination of nitrogen and hydrogen, two of the most abundant atoms in the universe. And it ended up getting mixed into the composition of planets and moons, and then played a huge role in shaping those environments. So any ammonia on the surface of Titan would have evaporated and helped to create the nitrogen-rich atmosphere and any ammonia below. The surface would have combined with water ice and allowed it to melt into various liquid form. So if we look at a cross-section of Titan, we have a solid crust of frozen ice. Then below that is a layer of partially frozen slush that occasionally erupts out through volcanoes. And below that, slush is where we believe that a thick layer of liquid water still exists on top of the moon's rocky core. There's just enough residual heat and ammonia to maintain a subsurface ocean. So, we have our water, and we have our hydrocarbons, and we know that by combining the two we get carbohydrates, which is the fuel for life. And we also know that through this active volcanic process, there is an opportunity for the two elements to meet each other either above or below the frozen surface. So, we're not saying that there are aliens up there, but there is the opportunity for some primitive bacteria to form that would meet the bare minimum criteria to be considered alive. And that is why NASA is currently investing hundreds of millions of dollars in their return to Titan with a mission called Dragonfly. This is a nuclear-powered helicopter drone that is designed to fly around the landscape of Titan and collect samples that will be analyzed by a mobile laboratory inside the vehicle. The plan is for Dragonfly to launch in 2028 and arrive at Titan by the year 2034. This will be a complex mission, but it's the only way for NASA to solve the mysteries of Titan. We'll find out what that sandy, snow-like surface is actually made of, and if there are signs of life out there, then Dragonfly will be our best shot at finding them.